So for A, we're saying that f of -3 is going to apply to one of these pieces. And so we're saying that x is equal to -3, and the piece that I want to use is 3x. So where the x is, we're going to substitute -3. So we get 3 times -3, and the solution to that will be -9. For part B, we are finding f of -1. That shows us that we are going to use 3x again because -1 is less than or equal to -1. So that means that we're using the function piece 3x, or 3 times x. So where x is -1, we're going to say 3 times -1 equals -3. For part C, f of 0. So the 0 is going to be part of the inequality for the second piece of the function. So the x minus 2, and 0 is greater than -1. So that's the function in yellow. So it's going to be x minus 2. We're saying that x is 0. So 0 minus 2 equals -2. And we have part D. We're asking for f of 2. We want to, again, concentrate on the inequalities. So since x equals 2, we're going to use the second piece, which is x minus 2. And you're saying that the x value of 2 is going to be greater than -1. So then when we substitute, we get 2 minus 2, and answer is 0. And then for E, we're looking for f of 4. Again, it's going to be the second piece of the function, which is x minus 2, because 4 is greater than -1. So the x is 4. It's going to be 4 minus 2 equals 2. Number 2, we're going to graph the piecewise defined function. So piecewise means that it has several parts of a function. I have -2 minus x if x is less than or equal to 1. And then I have -2 plus 2x if x is greater than 1. So this is a multiple choice problem. We need to make a table of values to create points so that we can match our table to our graphs, to our answer choices here. Okay, so I have the first piece of the function, -2 minus x, and x is going to be greater than or equal to 1. 1 is going to be my starting point when we're making our table. And remember that because it's less than or equal to, we're going to have an included point, so it's going to be a solid point. So we include the 1, and we say where x equals 1, we're going to input that into the -2 minus x. So I have -2 minus 1 will be equal to -3. And that's going to be an included point. So our ordered pair on the graph is going to be 1, -3. And we're going to have a solid dot for that point. Now we need a second number. So if it's less than or equal to 1, our second number should just be 0. So where x equals 0, I'm going to have -2 minus 0. And that's going to be equal to -2. So our ordered pair, or our next point to plot, is going to be 0, -2. So if you start looking at some of our graphs, it looks like A and C are both possible answer choices. So B and D are out. Okay, let's graph the second piece. -2 plus 2x. If x is if x is greater than 1. So let's make a table. We need to include the 1. And remember, this is going to be an open space. So I'm going to have -2 plus 2 times 1. And that's going to equal -2 plus 2. That's going to equal 0. Our order pair there will be 1, 0, and it will be open. Okay, so still A and C show this point. Our next number we're going to pick are going to be a number greater than 1. So that's going to be 2. So I have -2 plus 2 times 2. So -2 plus 4 is going to be 2. So our next order pair is going to be 2, 2. And that gives us answer choice C. If you want to graph it on your own, let's go ahead and do that. So we just kind of see what it looks like. So for our first, so for sure it's C. But again, just to graph it on our own, for the first part, like the part in blue, I'm going to have 1, -3. And that's going to be right there. And then the second point will be 0, -2. So I'll make that line like that. And let's highlight it just so you can see it a little bit more. Oops, wrong color. So that's that line. And then the next line is going to be the second piece, which is -2 plus 2x. X is greater than 1. So our first point is 1, 0. And that's open. And then our second point is going to be 2, 2. And so our line goes through 2, 2. And then when we highlight it, just so you can see, that's what our graph looks like. And again, the answer choice is C. The adjacent graph is obtained from the graph of f of x equals absolute value of x, or g of x equals the square root of x by applying several transformations. Describe the transformations and give the equation of the graph. Okay, so the first thing I want to recall is that the absolute function is a v, so our function is an upside down v. So that means I had some sort of reflection. If you're not familiar with the techniques, here's like the table that you were given in class. So let's go ahead and answer this. So we talked about this being the absolute function. So we're going to choose f of x. So the graph is absolute value of x. When we start in the center, it says translated to the left. We're looking at what's happening in our vertex. So we're going to go to the left 2. And we know it was reflected across the x-axis because it's upside down. And then it says translated up. So we went up 3. Right, so we went up 3 units. Okay, so let's go ahead and put this together. And we know that y equals, I'm just going to write it out here. So something's happening. I have an x. And let's think about it. 2 units to the left. If we look at our techniques of what's happening inside the function, that means that we're going to be adding the 2. So it's x plus 2. And then we reflected across the x-axis. So a reflection across the x-axis happens on the outside of our function. So I'm going to write a negative out in front. And then from there, I'm going to translate 3 units up. When I'm translating, that's happening outside the function, right? It's that step right there. So it looks like we're going to add 3. We're going to say plus 3. All right, so if you want to see it without all the color, you would say y equals negative x plus 2 plus 3. Remember, this is the h and this is the k. So we went 2 to the left, up 3. So that gives us negative 2 comma 3 if we had to talk about our vertex. Okay. The adjacent graph is obtained from the graph of f of x equals absolute value of x, or g of x equals the square root of x, by applying several transformations. Describe the transformations and give the equations of the graph, or give the equation of the graph. Okay, so this is a square root function, so we need to know the parent function. It starts at the origin, and then it goes to the right. And then we also need to remember our graphing techniques when we're setting up the equation. So it says it is the graph of, so I'm just going to start writing this in. It is the graph of g of x equals the square root of x. So in your practice test, it's going to be a drop-down menu. Okay, and then it is translated. So let's see, we go to the right first. So we start at the origin and then we go to the right. Let's translate it 1 unit to the right. And then from there, I go down. So I went 1 to the right, 2 down. So I go 2 units down. So let's go ahead and write out our equation. So I have x. Okay, so it says I have, let's see, I go to the right 1 unit, so that's going to be underneath the square root. Okay, so that'll be negative 1. And then it says that I go down 2 units. All right, so if I go down, that's going to be negative 2 on the outside. And then to simplify it, x minus 1 minus 2. So that, and if you are wondering about the vertex, or about the starting point, excuse me, that's going to be 1, perform the function operations and then find the domain. So let f of x equal 3x plus 5 and let g of x equals 2x minus 7. We're going to add f plus g and then find f minus g and then f times g and then f divided by g. Okay, so here we go. So so I just have the rules right here on the right-hand side for my function operations. So f plus g of x is going to be the whole term of 3x plus 5 added to 2x minus 7. So then my answer is 5x minus 2. And then we'll leave some space for the domain. So f minus g of x, you want to make sure you put that negative in front of the g because that's going to be distribution. So I write down what 3x minus 5, subtraction sign, parentheses, 2x minus 7. And then everything in the parentheses is going to change signs because of that negative. So I get 3x plus 5 minus 2x plus 7. When I combine this, I get x equals x plus 12. Okay, now I'm going to find f times g of x, or f times g, of x. So f is going to be 3x plus 5 times 2x minus 7. And we're going to set up our distribution. So I have 3x times 2x minus 7. And then I have positive 5 times 2x minus 7. And then I distribute. So I get equals 6x squared minus 21x. So that was 3x times negative 7. That's where I got the negative 21x. And then 5 times 2x is 10x. And then 5 times negative 7 is negative 35. I combine like terms. I'm going to get 6x squared minus 11x minus 25. And then f divided by g. All you're doing is making a fraction with 3x plus 5 divided by or over 2x minus 7. Okay, so now that we've answered all that, let's talk about the domain. The domain for f plus g is going to be negative infinity, positive infinity, because it says so right here. It says the domains of these function operations when you're adding, subtracting, and multiplying include all real numbers. And because both of these, the f of x and the g of x, are linear functions and their domains are already all real numbers, so that makes the domains for each function operation all real numbers. I know it sounds redundant, but trust me. So f minus g of x is going to be domain of all real numbers, which is negative infinity comma infinity, because we're expressing an interval notation. And then domain of f times g is going to be the same, negative infinity comma positive infinity. And then it's this domain for f divided by g, which changes everything. So what we're trying to do here is we're trying to basically, take the denominator right here, and we're going to say that it cannot equal 0. So we're going to solve for x. So solve for x. And we're going to say 2x minus 7 cannot equal 0. Minus 7, so that becomes positive 7 to both sides. I get 2x equals 7. Then I divide both sides by 2. So x cannot equal 7 over 2. So when you make this into a domain, it's going to have a union. So now I say my domain is going to be negative infinity, comma, 7/2, parentheses, union, give myself some space. The union symbol is like a U, right? Because that becomes a vertical asymptote. And then to complete that, I get 7/2, comma, positive infinity. And that's my domain. I know you can also, if you want to see what this last one looks like graphed, let me go ahead and show you. So this one right here would be 3x plus 5. You can also use your calculator. 2x minus 7. And if I graph it, I would have a vertical asymptote at 7/2, which is 3/2. This is equal to 3.5. So we come here. This is 1, 2, 3, 4. Right in here, I would have a dotted line. So I would have a function. Something happens here. And then something happens here. And that's what the function looks like. And just as an added, I went ahead and typed in all the solutions into the spaces so you can see how to present them for number 6. Is let f of x equal negative 3x minus 1 and g of x equals x squared plus 1. It's asking you to find f of g of x. So f of g of x is basically like you're going to substitute the negative 6 into the g of x, and that solution will go into the f. So let's write it like the notes. So again, the solution here, the answer here will go into the f, and then that'll give you your final answer. So here we go. So I want to find g of negative 6. That basically means that I have the function x squared plus 1. So this is acting as the x value. So we're going to substitute negative 6 squared plus 1 equals 36 plus 1 equals 37. So g of negative 6 is equal to 37. So when I rewrite this, I get f of 37. Because you're saying that g of negative 6, the solution is 37. So now I evaluate 37 in the f of x function. So when I do that, I'm going to get negative 3x minus 1 equals negative 3 times 37 minus 1 equals negative 111 minus 1 equals negative 112. And that is your f of g of negative 6 solution. Okay, this is number 8. This is from section 3.1, so I pasted his notes in here. Okay, so the number of mosquitoes, mx in millions, in a certain area depends on the June rainfall, x in inches. According to the equation, mx equals 10x minus x squared. What rainfall produces the maximum number of mosquitoes? Okay, so you're trying to find your solution. All right, so reading the problem, I need to know what my x represents and my function m of x represents. So x equals inches and y equals the mosquitoes because y and function m of x are the same. So I get 10x minus x squared. We are actually looking for the vertex equation. So to find this, because we have a, I guess he calls it the general formula, or we are going to use the axis of symmetry. So the first thing you need to know is that the vertex is going to be the axis of symmetry and then the value of the axis of symmetry substituted into the original function. So as we define our vertex, we're going to say that the vertex is going to be the x value, which is also equivalent to h. So the vertex means negative b over 2a. And I'll define it a little bit more. So let's talk about our a and our b. So I have a as negative 1 and b as 10. So again, the axis of symmetry is going to be h equals negative b over 2a. And now we're going to substitute our values in. I have h equals negative 10 divided by 2 times negative 1. So then I get negative 10 over 2. And when I simplify, h equals 5. So this h is going to go back into the original equation. And here's what I mean by the original equation. It's going to go back right here. Remember, because h is the same thing as x. So let's do that together. So when I substitute, and this is kind of an extra step, I'm going to say that I have m of 5 equals 10x minus x squared. So equals 10 times 5 minus 5 squared. I get 50 minus 25 equals 25. So that becomes our y. So if we're talking about the vertex, we're going to have 5 comma 25. But now we have to think about what our question is asking us. It's asking us what rainfall produces the maximum number of mosquitoes. So the rainfall, again, the rainfall is measured in inches. So this is the rain. So rain and mosquitoes. So our answer is going to be B. Number 9, find the correct end behavior diagram for the given polynomial function. So P of x is equivalent to 3x to the 7th plus 9x squared minus 1. I already have the answer choice on there. The answer choice is A, but let's talk about why it's A. So you take the leading term, which is 3x plus 7, and you talk about the type of function it is, and then you look at the coefficient in front of it. So when we say n is odd, we're talking about the exponent. So in this case, I would say n equals 7, and 7 is odd. Then I'm going to look at the coefficient. So the coefficient is 3, and that's going to be my a. So a is greater than 0. So we say a equals 3, and 3 is greater than 0. So we know our end behavior is going to be falling on the left and rising on the right. So it's answer choice A again. Find a polynomial of least possible degree having the graph shown. So this is an odd positive function. So on how to graph a polynomial, we need to locate the y-intercepts. Oh, the x-intercepts first. So that's where y equals 0. Okay, so that's everything in green. And then we need to locate the x-intercept, and that's where x equals 0. And we're going to do that in blue. Okay, first step 1. X-intercept. And then we're going to make factors out of them, like linear factors. So I have -2, 0, 3, 0, and 6, 0. So the factors I get from those is x, or it becomes the opposite, plus 2. If that's a positive 3, I have x minus 3. And that's a positive 6, so I have x minus 6. And then we talk about, that's step 1. Step 2 is going to be y-intercepts, or y-intercept. Just have 1. And that happens where x equals 0. So that means my y equals 18. But it's the order pair 0, 18. Okay, so if we want to break this down even further, we're now going to solve for A. On the left-hand side, we're going to use this value right here, the 18. And that's basically saying f of 0 equals 18. So let's start with the generic f of x equals a times these x-intercepts. X plus 2, x minus 3, x minus 6. So our f of x is equal to 18. And we're trying to solve for a. So that means our x is going to be equal to 0. So wherever I see an x, I'm going to put a 0. 0 plus 2, 0 minus 3, 0 minus 6. Because we're solving for a, 18 equals a times 2 times -3 times -6. 18 equals a times 32. We've got to solve for a, so we're going to divide both sides by 32. A equals 1/2. All right, so let's put this all together. Our polynomial is going to be f of x equals 1/2 x plus 2, x minus 3, x minus 6. And that is our solution. This is 3.5, question number 11. So determine which of the rational functions given below has the following features: x-intercepts -3 and 5, y-intercept -3/5, vertical asymptote x equals 5, and horizontal asymptote of y equals 1. So I'm going to build the numerator first with the x-intercepts. So remember, this is the numerator. And so my first intercept is going to be -5, 0. So that means I get x plus 5 because it's always the opposite sign. Next one is x is 3, 0. So that means I get x minus 3. So in my numerator for f of x, I have x plus 5, x minus 3. Okay, and then I have I'm building parts of my denominator with my vertical asymptote. And it says that my vertical asymptote is going to be x equals 5. X equals 5. So that means that my denominator has x minus 5. Then I have x minus 5. From there, it says the horizontal asymptote equals 1. So that means they both have to have the same power. That means I need to square my vertical asymptote. And then I need to check for my y-intercept. So the y-intercept happens where x equals 0. So let's try this. So we're going to test this. So where x equals 0, let's see what I get. F of 0 equals 0 plus 5, 0 minus 3, 0 minus 5 squared. So then I get -3/5. So this is my solution, and that's going to be option D. The second way to solve number 11 is to graph it. So when we look at what's given to us for the rational function, we can take a x and y plane and plot points based on the information given. So if I have an x-intercept at -5, that means at -5, my graph is going to touch or go through the x-axis. And then if I have another x-intercept at 3, that's another place that the graph will touch or go through. I also have a y-intercept, so that's going to, the graph is going to go through the y-axis at -3/5, which is like -0.6. So let's go ahead and start to label these. And then I'm going to look at my vertical asymptote. My vertical asymptote is x equals 5. So that is a line that my function does not cross. And then lastly, I have a horizontal asymptote happening at y equals 1. So that means right here, means right here going across, I have another area that my graph doesn't exist at, right? This is how we use the steps and the information that's given to us to graph a rational function. So now let's connect it. We know that underneath the horizontal asymptote and to the left of the vertical asymptote, something happens to those points, they connect. And then because I don't have any more x-intercepts, the second part of my graph is going to exist above the horizontal asymptote and to the right of my vertical asymptote. So you can graph this, or you can build the formula for this example, number 11. Most students will do both, but it's the same steps. 12, we're going to go ahead and build from the list using the graph. So we're trying to match the graph in the equation using the list. So it says the y-intercept. So if I look for the y-intercept, I'm going to get 0, 0. Then the next step says to look. So if you're wondering where I looked, I went right here. That's the y-intercept, and then it just happens to also be the x-intercept as well. Because the graph doesn't touch the x-axis at any other point. Step 3 is going to be the horizontal asymptote. The horizontal asymptote is a y value. And we can see that the horizontal asymptote is right here. So HA is y equals 3. So I want to convert that to my A over B argument. So that's actually saying that it's 3 over 1. So that is case 2. This one right here. Okay. And then we're going to look at the vertical asymptote. The vertical asymptote, you have 2 of them. And your vertical asymptotes are going to be x equals -3 and x equals +3. So x equals -3, x equals +3. Okay. I don't think we need extra points at this point right now. So we know that if we are building an f of x, that our function is going to be x-intercepts over vertical asymptote, right? And then our A and our B are built in there. So let's go ahead and put this together. Since my x-intercept is 0, that means that my factor is going to be just x, because x equals 0. So I get x divided by my vertical asymptotes, which are x equals -3, so that becomes x plus 3. And then where the x equals +3 becomes x minus 3. So x plus 3, x minus 3. And then I also need my A and my B. I go back to my horizontal asymptote for that. So I have 3 over 1. But this only works when my degree on top is the same as the degree on the bottom. So that means I need 2 degrees on top to equal the 2 degrees on the bottom. So I'm gonna put a second degree there. And this is our solution. The answer is gonna be B. So let's expand on the solution a little bit more. It's 3x squared, and then you take this part right here, and it becomes x squared minus 9. So then I get x squared minus 9.